The final impact category which we've looked at in the Marius project is the impacts of droughts on the energy sector. This is primarily work done by Ed Byers, who was a doctoral student of mine and did his PhD on water scarcity in the electricity sector, and is now at the International Institute for Applied Systems Analysis in Austria, which is why he's not here today. But he's going to be coming back to finish off this work with us as soon as they give him a few days spare at IASA. What Ed has done is developed a database in the UK of power plant location on rivers and indeed on the coast. What type of plant is it? What type of cooling facilities does it have? And what are the regulatory requirements associated with those rivers? And actually in other work he's looked ahead and looked at different portfolios of power plant which might exist in the future in a range of different energy scenarios. And then he's looked at the flow duration, at gauging stations associated with those sites, and in order to characterize the frequency of low flows at sites where power plants are withdrawing water for cooling water purposes. This is, we've heard a lot about uncertainties, and this is a particular uncertainty. There's a lot of variation at that low flow estimates, and there's a real variation in terms of how frequently low flow events are experienced at those different sites. So we need to acknowledge that uncertainty. Then connecting up with the Marius work, he's taken all of these flow simulations, both the synthetic event set for present day conditions and the future climatic scenarios, the near future and the far future. That's NF and FF for the yellow and the red. And on this axis, the x-axis is basically ranking these events in terms of severity, how difficult are these events for the power sector, and the y-axis is the amount of generating capacity which might not be available because of low flows which are restricting cooling water abstractions for the 40 power plants which are included in this analysis. And again, one can see a very wide range of uncertainties from in the baseline, very little risk right now of restrictions in cooling water availability, up at the other end of the scale, both the very high uncertainties and the possibility that in far future scenarios that impact on the power sector might be a lot more significant. Alongside the climatic effect, we've also looked at the hydrological uncertainties, which at that point on the flow duration curve are very significant. Ed also looked at when these low flows and impacts on cooling water might exist, and not surprisingly they happen in the summer months and in the late summer season, and this is significant because what matters is the interplay between power generation capacity and demand for power, and that is typically less in the summer season. So the work which we're doing now is beginning to look more carefully at the interplay between electricity demand and the availability of electricity supply. So looking at variability of electricity demand through the year and the effect and the climatic effects on that, and also the weather-related effect on renewables, as we have a growing proportion of solar and wind within the generation portfolio. So we need to look at whether renewables might be available at these times of low thermoelectric power and high electricity demand. And the lower panels also reflect the fact that we need to take into account the effect of electricity markets in this, the fact that there is some price elasticity on the demand side, and people can reduce their energy use and be incentivized to do so. Then looking over onto the supply side, and this is work we haven't completed yet, it's analogous, which is work has been done elsewhere in Europe, where one can look at the cost curve for different power plants. So if a thermoelectric plant can't supply because it has cooling water restrictions, then there are probably other plants across the country that can, but that has cost implications. So alongside that, there is the price effect, so the fact that increasing prices might suppress demand, and we look for the equilibrium between the supply effect and the demand effect to look at what might be the net effect in terms of, for example, consumer surpluses on this adjustment within the electricity market because of droughts and low flows and restrictions on cooling water abstractions. That's work in progress, but that will then feed into the economic analysis which Chris has just described.